Okay guys, hi. This is my first Arduino project. I think it took me like 3 months to get to that point. But all in all, today I will present you a very particular counter of time. Why particular? It's because my wife, she went to this music festival this summer and she liked it so much, so I decided to make her a present. This device will count how many days exactly there is left to the next music festival. So the setup is pretty basic, although we have quite many components. We have Arduino motherboard. I'm using Mega in this case. We have the standard 16 by 2 LCD display. Otherwise, we also have these 80-digit 7-segment LED display driven on Max 1719 driver. We have two potentiometer. We have one here, there, hidden on the whiteboard. This one regulates the contrast of the LCD display only. And also we have this one. This one is quite important because this one regulates the brightness of the LCD display as well as brightness of LED that I will use in the project. Speaking of LEDs, we have two of them. We have red LED. This one will flash with every second passed, and then also we have this yellow LED which also can be dimmed by the potentiometer, and I will show you what function exactly does it have. We also have two buttons. We have one button here hidden on the board. This one is a start and stop button, so this one will start the timer after some early setup. And also we have rotary encoder, so this is kind of like a button, but this one is not being pressed or pushed, but instead this one can be rotated, and then with the rotation left and right one can specify how much time there is left to the music festival. But this one also have another function, can be also pressed actually, so this is a push button, so it can be both rotated and also pushed. Yeah, it's pretty many components, many cables, but all in all, if you just look like here on the Arduino, all those cables, they go to the LCD display. Otherwise, we have only one pin that is used for regulating flashing of this red LED. And also we have here 3 pins. They are devoted to run the clock that will show how many time there is left. So as you can see, there's actually not so many pins being used from the Arduino. I don't know if Uno can be used for this purpose. I guess so. So I'm not going to explain everything here, but instead I will show you the wiring on the graph. So you can just pause and then study if you really want to reproduce what I did here. Okay, guys. So this is how the code looks like. As I said, this is my first Arduino project, so there is maybe not so much novelty in it. I was mostly inspired by multiple movies that I have seen on YouTube. I am posting the links to those movies in the code. But we are starting from loading the library to control the LCD. That's here, defining pins and so on. And then in the next step, we are loading the library to control the 7-segment display and all the pins. And then we are here we are defining different types of integers and functions. So we are starting from all the parameters to control this rotation button, this rotary encoder. So we are defining here 2 functions. So this output A and B. So this is basically two wires from the button that will respond whether you will rotate it to the right or to the left. And then it's connected to the pin number 10. So basically here we are checking the state of the rotation. So you will see later that we can actually control from here if it's rotating left or right. And then we are defining the state if the push button on the encoder is pressed, by definition is low. And then also here we have 2 functions. So the nice thing about that code is that each button, including the one on the encoder, can function into states, in the short press state and also in the long press state. So if you hold it for a little bit longer, it can do a different thing. So we have 2 functions, one for the short press and also for the long press. And then here we have 2 functions to define what is actually long. So starting from 0, if you hold it for 150 milliseconds, that's going to be long. So this is to control it. We also have another button, as I said, on the board, the small one. So this is very similar, and I'm going to go through it. We are defining LEDs. Importantly, the red one. I used to have this one controlled, but I don't, so I remove it. And then here are parameters for the time. So initial counter. So you will see later on the demonstration that you are requested to give number of days left. From now it's almost a year. So just to decrease amount of rotations that one has to do, I preset it to 150. And then additionally there will be a time measured down on the LEDs. So this will be showing 24 hours on the loop going down. So it's predefined to be 24 hours, and then it's going to go down. And then this number will be break down into digits, first digit, second digit, third, fourth, and so on and so on. And those digits will be stored in these integers. And then here, depending on what type of buttons you will press, and then how long they're gonna be pressed, you can jump through different type of modes in the code. There is idle mode that will be turned on when you turn on the timer, turn on the counter. There will be a setup one. Here you can set up how much time there is left to the event, and then the running one. So this one you start when you want to run your counter. And then you define, of course, the idle state. The idle state is idle. Okay, so when it comes to the setup loop, here you just, of course, define what kind of LCD you have, 16 by 2, and then here you are defining all the buttons. So this is 2 buttons for the rotary encoder, A and B. They work almost like a button, so that's why they go as input. They will receive the input, and then depending on whether A will get it first or B, then the device will know whether you are turning the encoder right or left. Also the pin for the button on the encoder. This is like a normal button, but normally for the buttons you select the input. I cannot explain you why, but this one only works if you actually have it to pull up, and it also has some other consequences later. And then another button, that's the start stop button. Of course, this one goes as an input, and then we have a red LED output, and green we again don't have. Here we just we wake up the 7-segment display. We intensity set to 1. I don't want it to be very bright, and then it's gonna be black when we turn on the device. And we will start by flashing all the LEDs will be on after you start the device, you will see. And then here you only just this is for the rotary encoder. Here you are checking the state of the of this A pin. This will be important later, so the device again knows like whether you are turning it to the left or right. We are printing some welcome message on the LCD display. This is nothing fancy, nothing important. And then we go to the loop function. So this is where the heart of the code is. Again, I am referring here to these very nice websites that I used as inspiration to build up parts of the code. So the main loop basically here. We are managing the buttons. Here we can see, we can tell whether you are just pressing a button or if you are pressing the button for longer. So you see now we are doing the rotary encoder pin. So if you press it, so because it's a pull up here, it has to be low, right? If we go, for instance, to the start stop button, so that's the normal button here. It was not input pull up, but instead it was normal input. Here it's high. So this is like a typical setup for the typical button. Again, I don't really understand why for the rotary encoder it has to be a pull up. I don't know. But anyways, the general rule is that you check if it's pressed. If it's pressed, then you are basically then changing the state of the function to be true. And then if you hold it for a little bit longer, then these if executes. If you hold it long enough, then on the other hand, this long pressed function, this one now will be true, and not the short press, and that will be important later. So we do this for both buttons, for the rotary encoder and for the start-stop button. And here we can switch between the modes. So we use this very nice switch case function. We start from the current mode, and then this is the idle mode. So this is the mode that is on when you turn on the device after you see the welcome message. So here you say that if the rotary encoder button is pressed for a long time, you can go to the setup. Instead, when you press the start stop, then you start the countdown, then you go to the running mode. So this is a very easy way to switch between different states to tell Arduino what to do. Otherwise, while this is ongoing, we are turning off the red LED. This LED will be only on at the beginning and then later on during the countdown. You can again ignore this green stuff, we don't have it anymore. And then we are presenting in the idle mode how much days they are set to the next festival. So we are showing how many days left, and then there is this variable counter that stores how much day is left. It is preset to 150, as I mentioned, just to decrease the amount of rotations one has to do, but it can be modified later, you will see. We have some delay for the stability, as explained. So if you hold the rotary button for a little bit longer, then you will jump to this setup mode. And again, here you can say that if you again hold the rotary button, you will go back to idle. If you press start stop, you will go back to idle. So this is really convenient. We are again now making sure that the red LED is off. This one is not important. And then here we can start adjusting how many days actually there is left. So we are just like here showing how much there is left. Counter, again, it's going to be preset at 150 as 150, but now what is in this loop, here we are just comparing how the input changes on these two pins coming from the rotary encoder. So if the loop here measures that they are differ, and they will differ if you just rotate it right or left, then the number of the value of this counter variable will increase or decrease, and then it will be in the real time projected in this counter value on the LCD. So you will see that by rotating, you will just see on the fly that you can modify this counter number. And then we jump to the running mode. So if you go back to idle and then hold the start stop button for a little bit longer, this mode will start. And what's going to happen here? Here the amount of days, a new variable will be set. So basically we will take amount of days set, which will be 150 minus 1 because we will show there is 149 days left, but then 24 hours will also go lower. So we are decreasing this by 1. Again, this is not important. And then here we are basically starting the countdown. Okay, so the count number, in this case, this is 24 hours. We will start decreasing it by 1. Here we are making some transformation to basically be able to change the digits on the counter. Importantly, this is, of course, we are gonna decrease the number of 24,000s. So this is not really how the time looks like. So just to accommodate the time into this mathematical projection, every time when we see 4 nines, so basically this we will see every time when 1 hour will pass, we will subtract 4,000 from the timer that is left, and basically this will change it to 5999, 59. So basically that's what we want to have. We want 1 hour. We want 1 hour to turn to 59 minutes, not 99 minutes. And then we do the same with seconds. So if you see that, if the Arduino see that there is 99 at the end, so that's what's going to happen after 59 seconds will pass, then we will subtract 40 from the value, which will turn basically 99 to 59, so we have a match for seconds. Okay, and now here we are storing different type. We are breaking down this string of characters, of digits, and then we are storing them in the variables. First number, second number, third number, and so on and so on. And then we can throw them into the LED display. So we are saying that on the digit number 7, this is the one on the left, so I don't know, it's the last one apparently, and this one will get a first number, and then the next one will get a second number, the third one will be empty, and then fourth, the fifth, the sixth will be also empty, and then seventh, F, and the last one will contain the seconds that are left. And then controlling the LED and time actually. So here we are, with every second we are turning the LED for a while and then turning it off, and then I have adjusted those values so then actually they match 1 second. So basically this code will go over and over again, and then those delays, they are defining how fast the time flies. So you can actually go from here to 10, for example, and then you will speed up the time much faster if you want, if you just want to test if your code is working. Okay, in this part of the code, what's gonna happen is that every time when this 24 hours will get to 0, it will be reset to 24, and then so basically a new day will start, or one less day to the festival. So this is why we are updating this amount of days that is left by subtracting 1 from the amount of days. And then everything, these days that are left, this will be shown on the LCD. So we are printing basically amount of days left on the LCD display, because again, all the how much time there is left, hours, minutes, and seconds, this will be shown on the 8 digits 7 segment display. A couple hours later, I managed to assemble the whole clock. So this is how it looks like. Everything is in the box. So let's just connect and then see how it looks like. I'm not sure if the camera can grab stuff from the LCD, but there is a welcome message now being printed, more like internal stuff. Hold setup button to begin. This is the message. The setup button is in the front, so this is the push button, the one that I can also rotate. I can click it and then it says adjust days, so I can now use this button, adjust days. It was 150, now I made it 170, and then I approve by clicking again. Now the value is updated as on the script, and then if you want to run, this is the button for running. So clicking, and there it is. You see the clock, 24 hours. Now this is decreasing. We have 169 days, so this is 1 day less than it was originally. And then another last feature of this clock is that is the potentiometer here on the right. So with this one we can fade away the LCD a little bit if we don't want to really look at it. And then there is one LED there at the top. I'm planning to put like a figurine that will be illuminated by the LED, so you can turn off them both using the potentiometer. So if I just turn to the right, you see that the LCD fades away first. The LED is much dimmer now, but if I then continue rotating, now the LED is completely off. Right, so that's it. Tell me in the commentary what do you think about this project, and good luck with yours.